record. Let me erase all of this again. All right. Okay, so topic 1, test review. All right. So in topic 1, test review, things that you have to familiarize yourself. The first one is for question number 1, you will need to know the key words equidistant, okay? Keywords angle. What is an angle? What are parallel lines? What are intersecting lines? Also, perpendicular lines. Okay? You'll need to know that for question number 1. You'll also need to know for question number 1 the word plane, and I'm not talking about an airplane here. Okay? So that's the question number 1. For question number 2, you need to know about reflection. All right. You should know about the little table that I went ahead and did for you guys, which is the X, Y. Okay. You should know about the reflection over the X axis, the Y axis. Okay. If you have coordinate X, Y, and it's reflected over the X axis, what are the new coordinates going to be here? Anyone?
Negative x comma y.
Negative x comma y. That's over the Y axis.
Okay, then negative y comma x.
There you go. So you need to know this. Okay. It's x comma negative y. Okay. So if I give you an example, if I give you a coordinate, all right, and the coordinate is going to be, let's say, 3, 3. 3, let's say this is 3, negative 2. Okay. The coordinate is 3, negative 2. Okay. And it's reflected over the x-axis. All right. Your new coordinate will be what, guys?
3 comma 2.
There you go. So you need to understand this part right here. All right. This is for question number 2. All right. So you will also, these are the rules. Okay. So I want you guys to understand that these right here are considered to be the rules. All right. Those are the rules. So if it asks you, what is the rule for reflection over the x-axis, you guys will choose this rule. If it says, what is the reflection over the y-axis, then you choose this rule over here. All right. For question number 3. All right. For question number 3, it talks about the transformations. All right. And it says, which of these is correct? Well, we talked about transformation. There's 4 types of transformations, right? What's the first type of transformation? Anyone?
Translation, dilation, rotation, and reflection.
All right, translation, dilation, rotation, and the 4th one is a reflection. Well, you're absolutely right. Now, in all of those right there, okay, we want to understand the word preserve. What the word preserve means to what? Anyone? I'll help you out. Keep the same. Okay? It keeps the same. So what I mean by preserve, it means preserves angle measure. So a couple of things that it could preserve, all right? It could preserve um, angle measure, or it could also preserve side lens. Okay? Now, translation is just a movement. Does it preserve angle measure and side lens? Yes or no? Anyone?
It does.
It does. You're right. It preserves angle measure and it also preserves side lens as well. So that's why I'm putting 2 checks on. Let's go to rotation. The rotation, does it preserve angle measure? Yes or no?
Yes.
Yes. Does it preserve side lens as well?
Yes.
Yes, it does. It doesn't change. Just because you rotate the figure, it stays the same. Reflection, does it preserve angle measure?
Yes.
Yes, it does. Does it preserve side lens?
Yes.
Yes. Now, let's look at dilation. Does dilation preserve angle measure? Got you guys thinking, huh? Well, here it goes. Ready? A dilation, it does preserve angle measure, and I'm going to explain to you why. But the side lens, no. It all depends if the dilation is going to be dilated by scale factor of what?
One.
Of 1. If it's a scale factor of 1, then yes, it will also preserve angle measure and it will also preserve side lens, okay? This is very important. So I'm going to explain to you about dilation a little bit more. So if we think about dilation here, okay? All right. Let's say if this is a triangle, 90 degrees, okay? And this is 30 degrees, and this is 60 degrees, all right? And let's say I make another triangle. This is also 30 degrees, and this is also 60 degrees. Notice that the triangles, the angles are the same. 90 degrees, 90 degrees, 30 degrees, 30 degrees, 60 degrees, 60 degrees. The angle measures will be the same. However, the side lengths, this is going to be smaller than this one over here. Okay? It's very important to point that out. Okay? The only time the side lengths will be the same is if, like somebody said it before, the scale factor is equal to 1. If the scale factor is not 1, then these side lengths will not be the same. All right, the only thing that will always be the same is the angles. The angles and the dilation will always be the same. All right. So far, so good. So when you read this here, read it carefully because it could be, it's very wordy, but it's not that bad. All right. Now, let's go to the next one. For number 4. Number 4, let's think about this. If it says same vertices and it's reflected, all right? I want you guys to understand something very important. If it's same vertices, what does it mean by same vertices, guys?
The same y coordinate?
You're almost there. In other words, it's not only like the same y coordinate, it's just same coordinates. Same coordinates. Okay? Means that the object is going to fall on top of the same object again. So for instance, I'm going to give you an example. Ready? So let's say if I have this here, this is my y-axis, this is my x-axis, okay? And let's say I have a triangle, okay? So to be more specific, let me do it again, all right? Let's do something else. Let's say if I have a circle, okay? If I do a reflection over the x-axis, will this circle fall on top of the circle? If I do a reflection over the x-axis here, will this circle fall on top of the circle? Yes or no?
No?
Oh. What quadrant is the circle in?
Quadrant 3.
In which quadrant would the circle fall in? Not on one. One is over here. This is 2, 3, and 4. There you go. It'll fall on quadrant 2. It'll go over here. You guys see it? So in other words, when I tell you guys same vertices. In this case, it doesn't have a vertices, but it was, when you hear the word like same vertices, it pretty much means on top of each other. So you cannot have this here. You cannot have a reflection over the x-axis because it's not gonna fall on top of the circle. So in other words, I'm gonna give you some examples where it can fall on top of the circle, a reflection. Well, guys, you guys learned this before. I say that's kind of like that, perfect. That's a reflection over the what, guys? You could type it in if you want, that's fine. That's not the y. Nah, no, the x-axis is here. The y-axis is here, which is this one here. There you go. Well, it's one or the other. That's fine. This right here, guys, this line is actually y is equal to x. That's y is equal to x. It's a reflection of y is equal to x. In other words, guys, this circle will flip right on that line. Okay? This circle will flip right on the line. Okay? So now, if it was here, this line coming down this way, it'll be y is equal to negative x. Okay? So you need to know those things. So in other words, I'm gonna go ahead and give you another example. So this is here. This is one way it will flip right on top of it, reflect. Okay? The other way, let's say we come back to the same circle, and let's say the circle is still here. Okay? We know that we created a line going in this direction. We know that line is y is equal to x. Well, if I make another line going in this direction, guys, and I do a reflection over this line, let's say this line is x is equal to what? -1, -2, -3, -4, x equals to -5. If I do a reflection over x equals -5, the circle is gonna reflect right on top of that circle. Do you guys understand that? Did you guys see what I mean? I could also do another type of reflection over this circle. Instead of saying x is equal to -5, I could say -1, -2. Let's say I do it right here. -3, -4, and y is equal to -4. That's the other type of reflection I could do. So not necessarily does it have to be x equals or over the x-axis over the y-axis. I could also say a reflection over x equals to -5, or I could also say a reflection over y is equal to -4. All right? So this is very important to understand about the parts of the reflection. That it doesn't have to be necessarily be reflection over the x-axis, reflection over the y-axis. You could change it around as well. All right? Okay. So that's that one, number 5. This is very important, okay? Because this one says a transformation that carries a figure onto itself. In other words, when a figure is carried onto itself, for this one, guys, I suggest you guys might be helpful if you guys are visual thinkers, you know, to have graphing paper. Okay? Graphing paper. All right? Because it tells you a reflection and it gives you rotation. And of course, you got to think about where is it being reflected, because it could be reflected on the side. And what I mean by the side, guys, so here goes some examples. Ready? It could be on the side. So if I give you this, guys, let's say if I give you a square, okay? And if this square is A, B, C, and D, if I tell you it's reflected on the side of AC, that means it's this one here. Then if it's reflected on the side, your image should be like that. Do you guys see it? Now, if I were to tell you now, this is on the side, okay, very important to understand that. Now, let's say if I say rotation, and I go back to square, and this is A, B, C, and D, and I tell you rotation on one of the vertices, okay? Well, one of the vertices, let's say is this vertices here, okay? If it's rotated one of the vertices here, and I tell you, if it's rotated one of the vertices, think about this right here as the coordinate grid, right? If it's rotated 90 degrees, then they'll be here, where what? A will be here, B will be here, and C will be here. If I tell you rotate it 180 degrees, then this object will be here, where A will be here, B prime will be here, and C will be here. So if it's rotated on one of the vertices, this is what you guys are getting as you rotate, all right? Now, if I say rotation on the square's center, so here was a key word, guys. Rotation on the square center. Well, guys, if this is A, B, C, and D, the center of the square is going to be right here. If the figure is carried onto itself, it means that it wants to be right on top of this here. The only way that this could happen is if you have a 90 degrees, 180 degrees, 270 degrees, anything less than 360. But if you have a 45 degrees, then your object might be going like this, which it doesn't work, all right? So this is very important to pinpoint. Now, for number 6, give me 1 second, guys. All right, guys, for number 6, again, it talks about transformation again. So notice how many times I'm saying transformation, transformation. All right, transformation that will produce something that is parallel. So guys, let's think about some characteristics of parallel lines. When something is parallel, let's say when two lines are parallel, what do they share? Anyone? When two lines are parallel, what do they share? Thank you. They share the same, very important, guys. They share the same slope, okay? Well, remember, this is very important because if they share the same slope, I'm gonna give you an example. let's say if I have this here, okay? And I have one line that goes like this, and another one that kind of like that goes like that, and then one that goes like that, okay? Well, they're all kind of going in the same direction, but there's only two of them that will share the same slope. In order for you to understand this, you need to know the slope formula. Well, the slope formula, remember, is the same thing as m is equal to y1 minus y2 over x1 minus x2. If both of the m values are the same, then therefore they share the same slope. Very important to understand that. All right. And the same thing goes for the next one, for number 7. It still uses the keyword parallel. All right. For number 8, it talks about the statements that justify the claim. All right. So you have to understand, you have to go back and find out, look it up. What does it mean by common vertex? All right. Find out what it means by common vertex. You should understand what complementary means. All right. You should also understand vertical angles, right angles, all right. Now, for the next question, all right, for number 9, it talks about multiple types of transformation. So remember I told you I like to do the chart with the transformation. This is where my coordinates start, which is x comma y. And let's say my coordinate is here, -3 and 2. And then if I tell you a reflection, so I'll write the rule up here, reflection over the x-axis. So if it's a reflection over the x-axis, my rule is going to be x comma y, negative y, I'm sorry. Okay, that's a reflection over the x-axis, and this is the x-axis. And then let's say the next type of transformation is, let's say this is coordinate A, okay? Will be a 90 degrees rotation. Well, the 90 degrees rotation will be negative y comma x. All right, followed, let's say, by translation. And then the rule for the translation will be x plus 3 comma y minus 2. So I like to do this chart to organize my work. So according to this, if it's a reflection over the x-axis, I'll go ahead and do this. This will be a prime, which will be -3, -2, followed by a 90-degree rotation. Remember, if it's 90 degrees rotation, would this be clockwise or counterclockwise?
Counterclockwise.
Always counterclockwise unless it is given. So this will be a double prime, which will be 2 comma -3. And then last but not least, this is a third transformation. So it'll be 2 plus 3. This will give me 5 at -3 minus 2, -5. and this will be my third transformation for A. Of course, you're gonna have to do, if this is a triangle, you're gonna have to do the same thing for B, and you're gonna have to do the same thing to C to get the final coordinates, okay? And the same thing goes for the next one, for number 10. If you follow this chart, you'll be fine. One by one by one. For number, let's say for number 10, okay, so you guys can know. For number 10, guys, it says choose all. So you have A, B, C, D, E, and F. You have to choose all the ones that work. Now remember, if it's A, B, C, D, E, and F, if you guys choose A and B, and let's say you miss out F, the whole question is wrong. All right, so it's very important to go to each one and see which one is the best one. All right, for number 11, talks about sequence of transformation. Whenever you hear the word sequence, it means more than one. Okay, it means more than one. Now, this is another one that's important. So let's say we go to this type of question. And let's say I give you this right here. This is A, B, C, and D. Okay? And let's say it's reflected over this line. Okay? If it's reflected over this line. Well, what coordinate would this be here? Anyone?
B.
Try it again. You're right, but you're not saying it correctly.
E prime.
There you go. So let's say if I change it around. Let's say this is A, B, C, D. Let's call this E, F, G, and H. Okay. Well, I could say this, guys. I could say that segment BC is going to be congruent. The little line means congruent to what? BC is congruent to what?
EH.
Very good. I could also say, let's take a look at this one, C. I could say angle, pay attention, BCD is congruent to what? Can I do this?
FGH.
FGH. Well, remember, look, I want you to take a look at BCD. Look at this right here, ready? And I like doing this.
EHG.
Good. But can we also say this, guys? This is very important. Please pay attention to this. Can I say this? BCD is congruent to angle GHE? Can we say that? Guys, what do you think?
No.
No? All right, let's think about this for a second.
I think it's yes.
You think it's yes? All right, let's think about this. Ready? Remember back in the beginning of the class, you guys learned, let's say this right here. Let's take a look at this triangle, all right? And let's call this triangle, this is A, B, C. And I told you guys, let's say this is 1. Well, if we want to describe angle A, I could say this is angle what? A. I could also say it, I could write it as what? Angle
1.
BAC, yes. Angle 1, or I could also say angle CAB. All of those are correct, right? So if you write it in this direction, I could also write it in this direction as well. This is very important to understand. The biggest emphasis, guys, that you guys know that the angles are the same is what's in the middle. What's in the middle? What letter's in the middle, guys?
A.
So these two are going to be the same exact angle. It's just another way of writing it out. This is very important. You have to understand, guys, this is something that a lot of students overlook because they think, okay, this is the only way of writing it out, and I cannot write it this way. No, you can write it this way. There's many ways of writing that specific angle. So that you need to pay close attention to. All right. Let me see what else. Of course, remember the chart I told you guys to memorize the rotation. This is something I told you guys. This is X, Y. This is rotation 90 degrees, 180 degrees, 270 degrees, and of course 360 degrees. This chart here, you guys should memorize. This is going to be counter. All right. I told you this is negative X, negative Y. This will be X comma Y. This will be negative Y comma X. And this will be Y comma negative X. This is for a counter clockwise rotation. This will be for a clockwise rotation. Remember the 180 and 360, they remain the same. The only difference is that this one and this one, they get swapped. So this will be Y comma negative X. This will be negative Y comma X. This you should know by memory. Okay? The other one that you guys should memorize is the part of the reflection. And we have, again, okay, and this is over the x-axis, and you have over the y-axis, and you have the next one over the give me a second, guys. Okay, x-axis, y-axis, y is equal to x, and y is equal to negative x. All right, and these are your coordinates. We talked about this earlier, which if it's a reflection over the x-axis, what's my new coordinate going to be?
X comma negative y.
Very good. If it's a reflection over the y-axis, what is my coordinate going to be?
Negative x comma y.
Negative x comma y. If it's a reflection over y is equal to x, what is my new coordinate going to be?
Y comma x.
Good. And then the last one, if it's a reflection over y is equal to negative x, what's my new coordinate going to be?
Negative y comma negative x.
Very good. Guys, you should know this by memory. Memory. All right? You should know that by memory. Now, the next part, all right? When you guys are looking at the test, all right? Let's say we talked about rotation. And very important keyword, again, we talked about it before, about its center. Okay, about its center. Okay, if you have a square, okay, the characteristics of a square is that what? The side lengths are all the same and it has what? 90 degrees. Well, one of the things that we could do with this here is we could find out how many lines of symmetry it has. Okay, and according to this, the square has 4 lines of symmetry. You have 1, 2, 3, and 4 lines of symmetry. So if this is the center and we talk about a rotation, I could ask the following question. I could ask you guys, which angle could the square be rotated so it is mapped onto itself? Okay, again, by which angle can the square be rotated so it could map onto itself? So again, when it says map onto itself, what am I referring to? Anyone? I hear crickets. Okay, when it maps onto itself, is that the figure, when it's rotated, it goes back to the original position. Again, it goes back onto its original position. In order for you to find this out, we need to know how many lines of symmetry. We talked about it has 4 lines of symmetry. So I could take 360 degrees divided by 4. What's 360 divided by 4? Anyone? 90 degrees. So this square, if it's rotated 90 degrees, it'll go back, it'll map onto itself, but not only at 90 degrees, also at 180 degrees, also at 270 degrees. Okay, I could rotate this 90 degrees. So in other words, let's say if this was the actual square, if I rotate it, you see right here, it does not map onto itself, but if I rotate this 90 degrees, it will be right on top of each other. If I rotate this 180 degrees, it'll be right on top of the object again. If I rotate this 270 degrees, it'll map onto itself. And of course, if I go back to 360, it's in the same spot again. We don't include the 360 degrees, okay? So this is very important. Let's try one out together. Okay. Now let's say we have the keyword regular octagon. And it has to have this word in the front, regular, okay? And the reason why it has to have the word regular on the front is because if it doesn't have the word regular, that means that the side lengths could change and the angles could change. If it has regular, it means that all the side lengths are the same and all the angles are also going to be the same. So let's say I'm going to draw it out. I'm going to try my best. It looks kind of ugly, but you guys get the idea. That's the octagon we're talking about here, okay? So in order for us to do this, we need to find out how many lines of symmetry does this octagon have? Well, I could do one here in the middle. That's one. I could do this one here. That's two. That's three. That's four. Well, I could start doing here too. Five, I do it here. Six, do it here. Seven, and I could do it here. Eight. So this octagon has 8 lines of symmetry. All right. So in order for me to find out, all right, which angle could the octagon be rotated so it is mapped onto itself, I'll take the 360 degrees, and divide that by 8. Okay. Which is going to be what degree, guys? Very good. It's 45 degrees. But it's not only at 45 degrees. So let's say if you have multiple choices, you know, just not only A, B, C, D. Let's say you have A, B, C, D, E, F, G, H, I, J, K, you know. It'll be at 45, will be one of them. All right. But we could also say 45 degrees. We could also say, what else? What's 45 plus 45?
90.
90. All right. What else? Is that it? Good. 135. What else, guys? Good. 180 degrees. What else? Good. 225 degrees. And we could keep on going just by simply adding 45, and we get 270 degrees plus, again, the 45 again, 315 degrees. And we stop at there. All right. The question will say anything that is less than 360 degrees, because 360 degrees, this right here, if it's rotated onto it from the center, at all of these right here, it will map onto itself. All right. We talked about that. We talked about that. We talked about the reflection. We talked about that. All right, you need to know definitions. So here we go, ready? You need to know the definitions. This is right in the beginning. You need to know the definition of what is a ray, what is an angle. We talked about an angle already. What is a point, and what is a line segment. All right. Let me see what else. And I think that's about it. Let me go ahead and stop recording.